All right. Hello, everybody. We are about to begin our fourth class. It's Introduction to Modules. Just before I begin, is there any questions or from last class you want to ask? Because I got some emails regarding some things that you guys want to confirm. And I think it'll be a great chance for us to all look at it as a group. So no questions?
No questions.
All right. Let's do a exercise then. So let's write a function that can do addition of two integers, okay? Then it'll return the sum. Let's just do that as a quick review for what we did last class. Anybody want to help me to do it? Or you guys want to share your screen and show how to do it? Oh yeah, enlarge the fonts. Sorry. So you just have a function, you take two inputs, okay? Two integers, or like, I should say two numbers. And you perform a addition and you return the sum. Nobody want to speak up? Come on, boys. And like, nothing to be shy about, right? There's no right or wrong about this. It's just a practice. Still no? All right. I thought that you guys had no questions.
I did kind of forget.
All right.
Like how to write the code.
Okay. It's fine. We can go back and look at it again. So where exactly did you forget about or not remember?
Basically the part that how to write how to make it do addition and then return the sum.
Okay, do you still remember how to declare a function? What was the key word, you know?
Let me see, it was len.
Not quite.
DEF?
Exactly.
Okay.
Def, we call it definition. Okay, we define something.
And then func, F-U-N-C.
All right.
The
Go
bracket thing.
Yep.
And then you write like ABC.
Okay.
And then you do like equals a number for each of them. Or something.
Okay. Here is where I want to point out, you only do the equal sign, okay? It's like this, right? But you only do it when you want to have a default value for C. But for now, we're just taking two numbers, okay? So meaning you only need two parameters here. And you most likely don't need any default values, right? So what I would change is, first of all, get rid of the third input value and as well as the default parameter, since we will for sure, pass in two numbers, right?
Yeah.
But you're on the right path, so let's carry on. What do I do from now? So I got my definition of the function's name called func, right? Let's just, so I have my name of function that is func. We have inputs that is A and B, right? And am I missing something in the declaration of the function? It's not complete yet. Yes. This is exactly what I'm looking for, right? So,
Can I
yeah.
write the code down?
Yeah. You probably want to put this down in your own VS Code. So Kale, is it? You can turn your mic up and speak if you want. But this is exactly what I'm looking for, right? This is perfect. Well, if I want to, so this just the addition and it prints out, right? That's perfect. But what if I want something on top of it? I want to return the sum instead of simply print it out. I
X,
just, yeah.
like instead of print, do like X equals that,
Okay.
and then do return X.
All right.
Does that work out?
This will work for sure. And that's perfect. Okay. That's what we're looking for. And
So all we have to do is just give it a variable.
well, you don't have to assign to a variable. You can just
You
say,
can just do return A plus B though.
yeah, you can just do like this, A plus B.
Mhm.
But I mean, assign a variable, there's nothing wrong with that, right? There's nothing wrong with this. And then we can check the result. So 12 plus 1, what does our logic sense tell us? What would the result be? Keep writing an extra. Well, it's 13. That's perfect. All right. So that's a quick recap of what we did last time, right? We learned how to declare a function using the keyword def, define. And we have a name of the function. We have a bracket. You can choose to have a values inside or no. It just tells the interpreter whether you want to have an input into this function or no, right? Then you have this colon. That tells the system that, okay, from now on, anything after this will be part of my function, okay? This is very important, this code. And then you do whatever calculation you want, and you can choose to return a value or no, right? You can simply do a print here, but a part of the little question is to return the sum, so you have to have the keyword return. And when you try to use this function, you just use by its name with a bracket and pass the input inside this bracket. It's like parameters. And the only reason why I'm having this outside print here is simply to show the result, you know. Or if you want, you can do it like this. You can say result equals this, and you can print out your result. It will be the same, right? It's the same. So now I hope it makes more sense. And for the ones that kind of forgot what went on last time. Yeah?
I'm not done copying.
Yeah, can you repeat it?
I'm just copying it.
Okay. But you understand what's going on, right?
Yeah.
All right. So everybody got this? I'll give you guys 2 more minutes and we will resume at 45. It's 45 now. So, any more questions? Or
No.
anything you guys forgot? I can show you guys again. All right, so let's move on to today's topic. Well, introduction to modules. Here is a new word, okay? Module. But we are in a high-level coding language, Python, okay? Everything, they are kind of the same of what it means in real life. So can you figure out what module means in coding?
Models of code?
Well, yes. That's exactly what it is, okay? It's just a piece of code that is put together as a model, okay? And when we think of model, we all played Lego before, right?
Mm-hmm.
There are different pieces, different models, and we build all the pieces together and we build a big plane or a car, right?
Mm-hmm.
So modules, they're essentially just code blocks that you
That
use
makes
as a little,
coding easier.
yes, they're like
Is it kind of like variables,
kind of,
but for code?
yes. So variables, you store just a single value, right, or a single data structure. But for modules, you store piece of code blocks. Right.
Wait, it's like I think I get it. In Scratch, you have those little blocks that you can put down.
Yeah. Also EV3.
Every one of those blocks, I think, are modules.
Yeah,
Yeah.
they're very similar. There's a little variation, and I will cover it in today's class, but they're most likely the same. Okay. So since we know that modules, they're like Lego bricks, right? We can move them around and build a whole piece. But in order to do so, we need a keyword called import. Okay? Import modules. Well, again, in English, what does import mean?
Import means bring in something.
What exactly? Okay. Import means to bring something in, something external. Okay. So when you import a module, it means import from an external file, an external code file. And some people may ask, why do I have to bring something in? Why can't I just write the code all in one big file? Okay. Let's say you have 1,000 lines of code you want to do. Why do I have to break it down into 500 and 500? Why can't I just have a huge file containing all 1,000 lines of code? Well, the answer is you can. There's nothing wrong with that. Just the readability of your code will be super low. You probably don't even understand how it functions, the relationships between each blocks.
Does that mean like what? Is it something like the computer can't read it or?
No, the computer will be able to read it. It's just you are a developer, right? And when you do a development, you work hand in hand with other people. And when you write some code, you're not the only one that's going to read it or put any like changes on it, right? Some other your colleagues, they'll come in and they'll try to read what you got, and they're trying to make some changes based on it. If you have 1,000 lines of code, they are not going to be able to figure out what's going on because it's not organized.
Yeah.
And in order to organize your code better, for the sake of human, eyes and our brains, we tend to break the code into pieces, and we only keep the most relevant ones together. So let's say I'm trying to build a car, right? Like not in computer science, I'm just trying to build a car myself, right? I'm not going to build everything all together, okay, at once. No, I'm going to build
You need
my
to make small
seats.
parts.
Yes, and I'm going to build my windows, like my glasses and all the wheels, all the engines. Then in the end, I'm going to put
Then
all
you just
those.
assemble it together.
Yes, I'm going to put all those blocks together, and I have a big car. The same thing with coding. when I break my big project into small pieces, it's easier for me when I develop them, right? I don't have to like have my minds all tangled up thinking, okay, now I'm going to work on part A, but all of a sudden I'm looking at part C in the code because it's too long. I don't know where I am. But when I break it down into pieces, I can just, okay, this file is called file A. This file is called file B. This file is called file C. When I work on it, I'm all focused, okay? There's no distraction from other stuff. I can focus on building my engine because you don't want a steering wheel to be in your car's engine, right? That's disaster. By breaking down your code, yeah, it will explode. By breaking down your code into small pieces, it's the same thing. And then you can assemble them later on. However, what's different from Lego and building a car is when you write once, you can use forever. What it means is, let's say you build an engine for a car, right? You can only use it for one car. You can't say, okay, I just manufacture one single engine and I'm going to use it for all 10 cars in the world. No, that doesn't work. You have to make 10 different other engines, even though they look the same. They do exactly the same thing. But for coding, you can simply write one block of code, store it somewhere, and then you can use it whenever you want for as many times as you want. There's no restrictions to that. And let's go back to the keyword import, right? When you use import, you essentially brings in the external variables, okay? The global variables, I should say. Well, all the global variables and functions. And functions inside that module. So here is a quick example. If I want to do a square root of a number, like number 4, right? We all know the square root of 4 is 2. But I can't really do that in Python directly because unlike print, square root is not a built-in function into Python. However, there is a built-in library called math, and that all Python interpreters have. Therefore, when you import this library, it has a function that's embedded inside this big module, okay? It's called square root. And then same way as you would use a function, you just call that function up and it'll give you the result of 2. We are all good till now. Everybody understands?
Yeah,
Any questions?
I know.
No? Okay. And let's see how we can make our own modules, right? Oh, if you are concerned that it might be something complicated, then don't be. Because this is exactly what we've done for the past 3 weeks or 4 weeks. So any .py files, they're essentially a module. The only thing you need to do to treat them as a module is to import them, okay, from other files. And here I have an example. In my, I have a first file called mymodule.py. All right, someone is drawing again.
So def say hi.
Yeah, just give me 1 second. Here we go. Here I have a file called mymodule.py, and I defined a function. Remember a function? And all it does is to print out, hi, this is my module speaking. Okay, just a simple printout. And then I have a global variable called version. Since it's my first round of coding, I'll call it 0.1. And then I have another file where I'm going to import this module, and it's called demo.py. What I'm doing is simply use the keyword import, and I import my module, and my module dot say hi. This is where it comes to be a little bit frustrating. You may ask, what is dot? Well, when I import a module, I imported everything that's inside it, right? But how do I differentiate from my original variables and functions in my demo.py from the ones that I just imported? Well, it turns out if you want to use anything externally, you have to use the name of that external library or module, and you have the keyword dot, meaning hierarchy. So whatever behind the dot belongs to the module that's before the dot. Okay, so module, my module dot say hi. You can read it as say hi from my module. So just think of this dot as from. And whenever you read anything in coding, you tend to read it reversely, so backwards. So you call the function say hi from my module. And then that's going to print out this line. And you can also reach your global variables that you stored previously. It's called mymodule.version. Same thing. You call up the variable version from your module. Okay? And that is all you need to do. Now, let's open up our editor and let's write our own code. So first of all, I'm going to have my my module, or like .py, and I'm going to say hi. Okay, I have a function called say hi. All it's going to do is have a simple printout. Sign the I am imported from external file. Okay, and I'll say version equals to 0.1. So that's my version of this code. And when I'm going to use it, I have another file called demo.py. I use the keyword import, and I import my module. And I simply say my module dot say hi. And then I can say, okay, print what's my version of my module. It's going to be my module dot version. So what I'm doing here it's the same as I showed you on the slides. I imported a module. I called up a function, and I retrieve a global variable from that module. And let's see what it does, okay? Well, it prints out that I'm imported from external file, and the version of my module is 0.1. And you've noticed that I don't have this 0.1 or this line of I'm imported from external file. I don't have that in demo.py. I just only need to do import, and I can use all those code. And for now, it may seem, useless because it's only 4 lines of code. Who cares? But later on, you will see that your module will be hundreds of lines of code, and you will find it very useful. So any questions for now? No questions?
Mm-hmm. No.
Anybody else? We have 23 people in this meeting right now. A couple are admin, and we have a bunch of students. None of you guys have any question or like any comments?
Mm-hmm.
Okay. So, okay, here is something I want to show you. I'm going to delete this folder for now. Just watch closely, okay, on here. And when I run the import, okay, when I run this import file, something is going to happen right here, right? You don't have to look at anywhere else, just look here. Whoa, a folder is generated automatically. What's going on? Right? Why? And it's saying my module does cpy, like does c python dash 36.pyc. What is .pyc? Why is it automatic generating this? It's called PyCache. What's that? Well, that is some fun facts about modules. So when Python reads the line import, okay, it will try to compile your code or your file that is being imported. In this case, it's my module. So that's why you see my module here instead of demo. And try to compile into bytes and then generate a .pyc file. It stands for PyCache when it's being imported. So because translating your code, high-level Python code into the low-level, the bytes format, it takes quite some time. And every single time computer does it, it'll assume that you are going to run this code again. You're going to import this file again. So to save time, it'll just generate a file, a PyCache file. So next time, if you haven't changed anything in your imported, in your module file, then it'll just going to read this PyCache externally, and for now it may seem to be very short, like a couple of milliseconds, but later on we have a gigantic project in some companies, like for Apple, Google, Amazon. It might take some time, you know. It might take a while, but reading from something you already have, it's going to be fast. And each module, when you try to import them, or you're just trying to run them, your system will give them a name. Okay, it's like everybody here. You know, my name is George. Some people's name might be Jim, maybe Tom. Okay, everybody has a name. And how does the computer differentiate if you're running this code by yourself or you're importing this code from somewhere else? It has a keyword. It's just called name. This is why I like Python. You know, it's like English. And this name can be different from time to time. Okay. When you try to run the code, like when you are trying to say Python 3 and the name of your file, like Python 3 and demo, your name will be main. Okay, inferring that this file is run standalone. However, if you decide to import this file from elsewhere, your name will be the module name. So, okay, here is an example. So name example. Well, that's not just here. Back to our my_module.py. Say if my name equals to main. So if I were to run this code by myself, I will simply say, okay, it's standalone. And let's see what's the name give us for now. And else if it's not, then I'm going to just print out that I'm being imported right now, okay? And let's check the value of name one more time. When I run this, okay, I'm running this file directly. I'm not running it through demo.py where it imports this. It's telling me the value of name is main, okay? That means I'm running standalone. However, if I were to import this file from elsewhere, like what I'm doing here for demo.py, then my underscore name will be my module. So it's the file name. It's the original file name that you are importing, okay? So it's the name of your module. Well, some people may ask what I'm going to do, like how is this benefiting me? Well, you probably want to do some initialization code when you are trying to import a file. Or in some time, you just want to have some test code going on in your when you are running this standalone. Let's say you are writing a database, okay? And you're trying to do some just testing around it. And you can just put your testing code under here, okay? So when you're running this code directly, this code will be executed. But if you're importing this database file from somewhere else, then nothing will go on, like nothing will happen. And it's quite handy. this is the same thing as in Java. If you ever learn Java, there's something called a main function. This is essentially your main function in Python.
Mhm.
Right? And like I'm saying here, you can use this to customize some behavior for your module. And remember, this only works at initiation of your function or your module. So you can see when I try to import this, even though I'm printing out like all other stuff here, right? But the first line that's being printed out is here, this. So this line of code, they will always be executed when you run this file, no matter you're running it by itself or you're running it from somewhere else, okay? This is the first line of code the computer is ever going to read. It doesn't matter what you have like above or below. This is the core function that is going to go top priority no matter what. So if you want to have some basic settings going on around your environment, then I recommend have them inside here. Okay. If you have elsewhere, you probably end up not doing it at all. So, yeah.
I'm sorry, but how I wasn't here for the start of the class. How do you make a module?
All right. So a module, they're not different from anything we've done before. Okay, they're exactly the same. In fact, they're just a file, a regular file. It ends with .py. So this demo file, this is a module. This my module file is also a module. This review file is also a module. So anything ends with a .py is a module. And by saying a module, it means it's a piece, okay? It can be put it on some other code. Like it can
Is
be
there
added
any
on
other
top.
way to do modules?
No, this is the only way. Because a module in Python, it has to be something that's a Python code, right? By that, it has to be .py. And when you're trying to use it from elsewhere, you have to use the keyword import. That's the only possible way you're going to run this code. So if we go back here, like here is just a definition of it, right? So you just need to import it from other files. Does it answer your question? All right. Oh, is that?
Can we import the module anywhere in the code?
Yes. Yes. Well, since I said that my module, like this name equals to main, this one will always be executed whenever you import the file, right? Whenever you interact with this file. If you don't do it at first, then it will not, be called up at all. So I can say start of my demo. If I do it like this, then nothing will go on. Like, okay, my print statement will be executed first, then I will import my module. And you can even import this in an if statement. So its effect will only exist in the if statement. Or you can say something like, if, well, condition. I have a condition that's false for now, right? I say if my condition is true, then I will import my module. You can even do something like this. So the import statement, it doesn't really matter where it is. It's just, you can do it anywhere. But normally what we would do is just at the beginning of the file, okay? We have it right at the top. And this is where I like Java and C better, because in those languages, they restrict you, they force you to write this line, like this import statement at the very, very top of your
Wait,
of
this
your
is
code.
there will be a recording, right?
Yeah,
Okay. So I'm gonna need a recording.
no, you can just ask anything right now.
Oh, so I kind of didn't get the how you make a module.
All right. You understand that module, they're just files, right?
Mm-hmm.
So when you write any Python code, they're
Oh,
already
you
a
so
module.
you like bring. So you write. So you import the name of the file.
Yeah.
Oh, okay. I get it now.
So for example, here, when I try to use the external code from my module from this file, all I'm going to do is just have its name here. But you never write .py, okay? You don't do something like this, no.
Okay.
You just go like my module. All right?
Mm-hmm.
Any more concerns about this? Any more concerns regarding the declaration of a module and how to work with it? No? All right.
Nope.
So, wow, I did not expect this class to go on this fast. Our last slide, I talk about how to organize some packages, okay? Or using packages, I should say. Previously, we've learned about variables, functions, and some global variables, right? The ones that exist in the form of the top level of your module, right? Because you can have some variables, they only exist in the functions, or you can have some global variables that they're on the same hierarchy as your functions. And then we have modules. So like I listed here, they're kind of embedded inside each other. Variables, they belong to functions. And functions and global variables, they belong to modules. So they're kind of organized in that way. But how do we organize modules? Or in another word, how do we organize the .py files? Well, you think of just organizing your computer. You have some pictures and you have some documents. You just put them in a folder, right? Or you put anything grade 9 related to a folder named grade 9, anything grade 10 related to a folder named grade 10. And you have all the grade 9, 10, 11, 12. You have all of that in a folder called high school, right? It's the same thing. You put all the related, okay, I'm mentioning this word related files in a folder. So it's the same thing as how you organize your regular computer. But you have to remember, when you put these modules in a folder, the computer doesn't know that this folder contains so many useful stuff, right? It doesn't know, not at all. So normally we use a init.py file to tell the Python interpreter that, okay, heads up, this is a very special directory or folder, you can say, that it contains many modules. It contains many Python codes, so treat it differently. And in a new hierarchy, it will look something like this. On the very top level, we have North America. Then under North America, we have Canada. Okay. If you see this little slash here, it means it's a folder. So under folder North America, we have folder Canada. However, we have to let the computer know that folder North America, this is a special one because it contains the Python code, right, underneath it. So we need something called init.py. And this init.py is actually the same as name equals to main, okay? This will run at the initiation of your module or your folder, right at the top. It never changes. Do some initiation settings, or you can have nothing here, nothing going on here, but it depends, really depends. And then you have Canada, and under the folder of Canada, you have another folder called Ottawa. At the same time, you have init.py because, okay. Because this folder contains some Python code in it, right? And under Ottawa, you have another init.py because the folder of Ottawa contains a .py file here. It's called Beavertail. Okay, we have some Beavertail. And this is kind of the hierarchy that we're looking for. And under Beavertail, you may find many, well, Beavertail here, it'll be a module, right? And inside this module of Beavertail, you may find a function called how to make Beavertails. Or you may find a global. Yeah.
If you don't give it any clear instructions and you just do import whatever module, would it just put down all the entire code inside?
Can you repeat your question?
I said, if you import a module or file, but you don't tell it what to print out, will it just print out the entire thing? Like all the code inside of it?
What do you mean tell it what to print out? Like when you import a module, you're not printing anything out.
I mean, like, how to say it? Not print, but it's,
You mean, are you importing everything that's in the
like,
file?
are you importing everything that's in the file? Yeah.
Yes. So think of it as, like I said, Lego or a car. When you build a car, when you put an engine into the car, you're not just having half of the engine in the car, right? You're having the entire engine in the car. Same thing applies here. You're importing everything that you have. All right, for example here, when I do this import my module, I'm importing everything, okay? all the lines of code I'm having here. I'm importing everything into this. But normally when we use a function, we simply use the function's name, right? Like this. But when I try to use a function that's in the module that I just imported, I need to use the name of my module and use dot, declaring that the function belongs to my module, so the computer knows where to find it. Since if I just simply say hi, then there's an error saying, okay, undefined variable hi, because the computer doesn't find any say hi function inside this
Yeah,
file,
so
right?
there's only the module.
Yeah, you have to have the name of your module and use a dot. There is a way that you don't have to use dot. Let me go back to this after I finish the last couple of sentences, right? I will show a couple more ways of importing stuff.
Mm-hmm.
So that's how you're gonna organize a packages, right? And inside this beavertail.py, you probably find some functions, some global variables, and inside the functions, you probably find some variables, right? How do I make a beavertail as a function? And inside that, you may find a variable called how much water I need. Okay, water, and it tells you how many liters of water to need. A variable called flour tells you how much grams of flour you need. Like a syrup, how many maple syrup you need, right? Those are all type of things that you can have in a module. But over that, you have a big folder that's called packages. It goes layers by layers by layers. And that makes sense, I hope. Yeah.
Yes.
Everybody else, all makes sense? Yeah. Probably need a little bit more interaction going on here, boys. Well, okay. Seems people don't like to talk that much.
Mm-hmm.
All right, so like I said, there are different ways to import a module. For this one, I just imported module and use its name to call up the variables and functions that belong to it. However, if you decide not to use this, if you just want to use the regular way of calling up a function, you just want to, okay, I just want to use say hi, and I want it to work. I just want to use version, and I want the computer to know what I'm talking about, because for now, regardless of this little red lines showing you here's error, when you try to run it, it's going to be an error, right? Like, it's bad. What you can do is from my module import star. What this does is it tells the computer that I'm importing everything in the module, because previously I'm only importing like my module, right? I'm importing this entire thing. But if I do this with a star, then that means I'm importing every single pieces directly. It might be tricky when you try to think of it, but again, let's go back to the Lego example. If you say import my module, okay, so this one, it means bring me in a bag of Lego bricks.
Mm-hmm.
And whenever I want to use this, let's call it bag one. Okay, whenever I want to use something from bag one, I'll just say, bag one, give me block A, or bag one, give me block B. Right? That's how I'm going to interact.
Yeah. Okay.
But if I do it like this, then that means dump everything that's in bag one into my current playground. Okay, so whenever I want to use it, I can just grab it up.
Mm-hmm.
Same way as I grab anything else from my playground. Okay, let's say I just have 10 pieces in my bag one. I dump them all on the ground. Whenever I want to use one of these 10 pieces, I just grab it and use it. I don't have to tell bag one to give me those pieces again because they're already on the ground, right? They're already around me. All I have to do is pick it up and go.
Mm-hmm.
So if I do it this way, I can just simply use say hi and version like a regular variable or a regular function, no difference from your native ones. By native, I mean the original ones belong to the file that you're running. So if I do it like this now, that's going to work, right? Everything works out perfectly. However, if you choose to do it like this, if you choose to bring in the entire bag instead of dumping them all on the ground, then you have to use the my module dot. You have to tell bag one, okay? You have to specify, okay, bag one, give me say hi, give me this function, okay? Or bag one, give me this variable. Those are some rules you have to follow. And some other people, they may say, my module, the name of it is way too long. I just want a simple letter regarding my module. I just want M stands for module, okay? Well, that works too. So it's
you can just do my model equals M.
you mean M equals to my module, right?
Yeah.
Yes, that's one way. And you can say M dot, right? That's one way. However, that still requires one more line, right? And what if I want to do it all at once? I use a keyword called as. So import my module as M. So this tells the system that now M is a special character. It represents my module, and I can run it, and it's fine. But just to be careful that when you do it like this, you're still bringing in the entire bag, right? You're not dumping any pieces in that bag on the ground. So you still have to use the keyword and use the dot. You have to still use this format. And sometimes when your module is too large, right? You're only trying to use a couple functions from your module, or you're only using one single variable from your module. You can use the keyword from again. And just say from my module, you can import some things. Instead of using start, which represents everything, you can just say, okay, I want my say hi function, right? And now, like I said before, this specifies that you are grabbing the say hi function from this bag directly. So when you try to use it, you don't need to go like my module.say hi again. No, that's not needed. You can simply just say
Can you get
function
that?
name.
Give that command like a variable or a module.
It's valuable.
You mean give this function a variable? So
Yeah, give this function
a
variable.
equals to this.
Oh, okay, yeah.
You mean like that?
Yeah.
No. If it were a variable, so if I were to import a variable like version, and I let v equals to my version number, okay? That's perfectly fine. This is okay. And you can even do sv. So from my module import version sv. So it tells the system that I'm importing, okay, I'm importing version from my module and I give it a name called v. But if you were to do a function that won't let you do it, and it's not only for modules and importing, it's banned across all platforms. Okay, even if you are writing a function like this, well, you can assign it, but it's different from what you're expecting. This does not mean to have everything this function does and assign it to this variable. No, this is the difference between that and this is I have the keyword return. So if you don't have the keyword return, you cannot do something like this. Since I returned a result of my function back up, then I have a variable when I run this. I have a result when I run this code, right? And that result belongs to this variable, right? My result of the function they will become the value of my variable result. But because that I don't have any return statements here, I cannot use the assign function. However, if instead of using print, I change my coding to return, then now I could just do it like this. And now my A will simply be the value of my string here. It'll be this string. And we can see it. When I do it, it'll be I'm imported from external file. That's all it does, right? And a more visual way of doing so is I can have a print statement whenever this function is called up. Let's say function is called up. I don't need this line anymore. And when I run it like this, you will notice that my print statements, when I use the function, it only appeared once. But if I were to print my value twice, then the only thing going to repeat is this line, because that's what I returned. Okay, that's the value of this string instead of the entire function. Any more questions?
No.
Nope. All right. That's all I've got for today. It's only what, 70 minutes. We do have the time to cover a little bit more. Do you guys want to leave early, or do you guys want to listen me talking for another 30 or 40 minutes? You want to leave? All right.
I would leave because I think practicing the what is it again? Practicing the modules should be enough for the week.
All right. All right. Okay, so for the guys that want to leave now, you guys feel free to leave. Depending on how much people want to remain, I might do something about some data structures. Like we mentioned, list, set, dictionaries, and tuples in the beginning, and we only covered list.
Yeah.
So if
So,
anybody is interested to that, you can stay. The others, you guys can leave.
okay. Thank you. Bye.
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 Yeah, that is a good suggestion. Okay. Do you guys rather do a activity to practice what you did today, and we can combine it with the functions that we did last week? You guys want to do an activity, or want to just do some more learnings? Your choice. Let's do a show of hands. You can either use your mic or you can type in chat. Either way works. Review. All right. You want to review about today's lesson or like last time? Because I did receive some feedback saying they have some questions about functions. So last week? All right. Is there a specific part you want to go over? And regarding about the magic of string. Okay. So, okay. Here is what we're going to do. Let's have a module named calculator, right? And inside the module, we have some functions, okay? We have addition, subtraction, multiplication, and division. We want to have these 4 functions. I should have brackets. And we want another file named student, okay? And the student want to use the calculator to perform some actions. All right, so this is what we're gonna do. We want to make a calculator that can do the 4 basic calculations, right? Addition, subtraction, multiplication, division. They will each taking 2 parameters, okay? Parameters A and parameters B. A and B. So addition, it doesn't matter. Multiplication doesn't matter. So, but for subtraction or division, it's going to be A minus B or A divided by B, okay? So you have 2 parameters that's being passed into your each of these 4 functions. And for subtraction and division, you're using A as the first variable and B as the second. You want to do A minus B, so first variable minus second variable. And for division, you want to use the first variable to divide by the second variable. And you want to return the result of the function. Okay, this is what you want to do in the first module. And in the second file named student, okay, he's having a math test and he wants to do some calculations. He wants to do like, what's the value of 5 point plus 1.7? Okay, that's question number 1. Question number 2 is, what's the value of 7 divided by 3? Number 3 is, what's the value of 5.3 minus 9? The value of. The last one is, what is 7.3 times negative 8? All right, but this student is not allowed to use the actual, the mathematical operations that we learned before in Python. It's only allowed to use their own calculator, like our customized calculator. So let's help the student out. Right, first thing first, what do you guys want to do? What's the first thing we're going to do here if we're trying to make a calculator? Well, since we're using a module, then we need to create a file, right? The file's name will be named the calculator.py. Yes, you want to set up the file and make the functions. So first of all, you have a file called calculator.py. Inside that, we have to define 4 different functions. So function 1, it'll be addition, right? Okay, actually, I want you guys to do it. How should I declare this function? We've done this at the beginning of the class, and I want to do it again. Okay, we did in this review.py, but I'm not going to show you guys. You can either type in the chat or you can use your mic to tell me what to write here. All right, def addition A and B, okay, and they equal, perfect. So we defined a function here, and its name is called addition. We pass in two parameters, two exactly, A and B. All right, what do we do now? Right, so we want to return the value of the sum. So A plus B. But that's perfect. Okay, so that's it for addition. What should we do for the next one? Let's do subtraction. Subtraction, it should be very similar with addition. You just have to change your function's name and your operations inside it. Well, still waiting for my chat to help me out here. Still waiting. Okay, so now I'm trying to write a function, right, for another calculation. It can be subtraction, it can be multiplication, or it can be division. And how should I write the next function? All right, so subtraction. That's perfect. Subtraction A and B. And we can return the value of A minus B. That's exactly what we want. Okay, so what about our okay, that's quite a lot. All right, addition, okay, subtraction, multiplication, division, okay, even remainder, even power. All right, okay, seems to be Harper is really on top of things. Already finished everything. Okay, so we want multiplication now. And you want to return A times B. And for the division, you want to do A divided by B. He even he even went beyond to have remainder and power. Okay, so we're gonna follow that. Remainder and power. All right, that's perfect. So now we have a student and he needs some help. How should we help him with our customized calculator? Here are some requirements. And we even want to have the power, like what's the value of 2 to the power of 8, and the remainder of 7 divided by 2. Okay, these are 6 questions. How are we going to help the student? Well, first of all, we want to use our own calculator here, right? How can I use some code that I wrote externally in my new file? We want to use the keyword import. Okay, we want to import those code into our new file. Like I showed you guys before, we have a couple different ways to import a file or to import some modules. Well, I'm going to use the most used way, okay, the traditional way, just import calculator. But I don't like writing calculator. It seems to be too long. I just do scal. Okay, cal stands for calculator. Oh, no, don't want that. And now I have a calculator already imported. Now I want to perform some of my calculations. Let's do a 5.7 plus 5.4 plus 1.7 first. Okay. So question number 1, we want the result of that to be addition, right? So we use the new name that we gave to our module. It's called cal. And the dot declaring that I'm going to call up a function that belongs to this module. And we use addition. We pass in 2 numbers. Okay, 5.4 and what was that? 1.7. And now we want to check what's our value. Well, it should be 7.1, but oh, not running the right file. And there we go. We have 7.1, but with many zeros and a small 5 in the end. Why is that? Well, I'm going to mark that on my notebook. I'll try to answer this question next class, because I think I've saw the reason behind it somewhere, but it was a long explanation. I'll try to look into that next time. Let's just assume that's only 7.1 for now, okay? And we want to for question 2 as well. Okay, question 2. And let's do a division, shall we? 8 divided by 3. And let's check the value again. Okay, we have 2.6. That seems to be right. Well, what's the new calculation you guys want to do? You guys want to check? No? All right, let's just check the 2 extra ones that our good friend Harper that gave us. Let's do power, okay? There's a power of 2 to the power of 3, okay? And that should be 8. And let's do another question 4, okay? It'll be remainder. What's the remainder of 9 divided by 4, okay? Let's check that. Well, it turns out it's 8 and 1. Well, our calculator is pretty amazing, right? We got all the functionalities and everything works out. So, really good job. I hope you guys all have a better understanding of today's class, all right? About the import, so the module, how that functions. And how to write a own function. Well, here is okay, you want to do division of 0 by 0. Let's see what that'll give us. I think it'll be an error because it doesn't support anything divided by 0. Can the computer unlock the secrets of the universe? Well, let's see. No, there's an error. Yeah, it cannot be divided by 0. Probably not. Right. So I hope everybody have a better understanding of how modules and functions they work by now, right? However, for calculators, how about let's take it a step further. Now we're having all these functions, one by one. But can we just have one big function, okay? One big function that it takes in 3 different parameters, okay? I'll write it here. Can it be a big function takes in 3 parameters? It's A, B, and a calculation type. And based on the calculation type, it'll perform different actions. So perform different actions based on user input. Well, in this case, the input will be your calculation type. If we want to write a big function that does all this, how should we change our code? Well, let me give you guys a hint. We want to use a control flow. Remember control flow that we talked about before? We have 3 different control flows, and they are if, for, and while. Well, among these 3, which one controls like a switch? Which one performs like a switch that it gives you different result based on your different inputs? Which of these 3? Well, not for. For is you repeat. Okay, I'll write the definition here. For is when you repeat certain actions for a set, I guess, set amount of times. So when you use a for loop, you can ask your system to do something for 4 times, for 5 times, for 6 times. But they only repeat the same thing. It never changes based on your user input. No, it doesn't change based on that. Yes, we use if. But since we're here, I will do a quick recap of what while loop does. So it repeat again same certain actions. Instead of for a certain amount of times, it repeat until the condition turns false. So it'll repeat the stuff on and on and on until, well, the week turns into Monday, right? You will repeat something until something happens. So you probably repeat the action of going to high school until the age of 18. You repeat the action of going to university until the age of 22, I mean. And if, exactly, if is the answer that we use if. So it controls, it gives you different action based on different conditions. So now we know that our champion is if. So use if. How can we use if and help us do this? You don't have to write the entire code and paste it in chat. Just let's brainstorm together and let's see if we can come up with an answer. How shall we use if to control the flow of the code so that we perform different actions based on the user input? Well, let's make the calculation type a bit more precise. By this, I mean a string, okay? a string is either called addition or is called let's short it up. It's either called add or minus or divide or multiply. Okay, let's only do the basic 4. So if I have a calculation type that is a user input, and it's going to be one of these 4, and I want to perform different calculations based on my different user input. How should I do this? We know where I want to use if. Okay, since we're running a bit short on time, I will start writing code now. I'll show you guys. But still feel free to write anything in the chat. Okay, I'm just gonna have a new big function called advanced calculator. And taking 3 parameters, like I said before. I have A, B, and my type. Okay, and I want to use if. So how should I use if to improve this or to make it different? If my type equals to add, then I will return what? I'll return the result of A plus B. Else if my type equals to minus, I want to return the result of A minus B. And on top of that, if my type is what? Multiply, I want to return A times B. All right? Or else if my type equals to divide, I want to return A divided by B. However, it may occur that your type might not be one of these 4. So, and all the exception cases, they will occur as else. So how if statement does is going to check each condition. Does it satisfy the first condition? Is it equal to add? If it is, it's going here and it's going to finish this, okay? Since I'm saying return here, so it's not going to do any further things. It's just going to end this entire function here. Yes. Yep. KO it is? Yeah, you got it. You got it. That's exactly what you should do. Except that you have to be careful that your multiply or like any of your type, those have to be string, right? So you want to have a single quotation mark around this. Same thing applies to add, sub, multi, and div, okay? And as well, you want to use some extinguishable variable names. So instead of C, since A and B, those are two numbers, right? C just makes it seem to be the third number. You want to use something like type. So when people read your code, they know exactly, okay, here is the type of the calculation, right? And in the end, if it doesn't satisfy any of these requirements, I'm just going to say, okay, else. I'm going to return a string saying, sorry, invalid calculation type. All right? That's all I'm going to do here. I'm going to say, sorry, it's not valid. I'm not going to use it. And when we try to use it, again, here, I'm not going to delete it. I'm just trying to do the same thing. Or let's just do an addition, okay? So now, again, question 1. I'm just going to be addition, 5.4, 1.7. Now I want to use my new advanced calculator, right? And here it asks me to pass in 3 different parameters. For number 1, number 2, and a calculation type. Number 1, that's going to be 5.4. Number 2 is going to be 1.7. Okay, and what's the type of my calculation? I want to do an addition. So I'm just simply going to say add. And let's see what the result is. It gives me 7.1000, many zeros and a 5. So 7.1, which is what we're looking for here. And same thing applies. We can have question 2. We can have another advanced calculator. We want to do a division now this time. We want to do a 9 divided by 2. Okay, 9 divided by 2. I want to do a division. So the type, it has to be a string, and we'll call it divide. I'll print out the result of our calculation. .5. And this is how you're going to have a rather more complicated function that requires not only calculations and return statements, but requires some control flow you have to do, like if statements. You can even do for and while, but those are not particularly required, or they're not suitable for this case, this scenario. Any questions? No questions? Scroll to the bottom, like on which file? Here? This one? This one? Okay, like the bottom, like this? Nothing's here. right? All right, okay. Anybody else got any questions? It can be regarding our advanced calculator. It can be regarding any questions from the past 4 sessions, well, including today, or it can be anything in general about coding, Python, or other languages if you have any questions, concerns. All right, so how to accept user input from keyboard? Well, here we simply want to say the it's very simple. You have just the function, it's built in, it's like print. Okay, everything is already embedded inside. You don't have to import any other modules. You just use the keyword input, and basically if I'm doing this, let's say in equals to input, right? And I print whatever value it gives me. Well, okay, user I want to print out my user input. When I run this code now, it's not going to print anything. It's going to wait here. I have to type some stuff, okay? And now when I hit enter, it's going to print exactly what I typed. And it's going to take all the strings I typed since the moment that this code is activated, all the way to the point where I hit the key enter. So when I hit enter, it means the end of this line. So this input, it just means take the entire line that the user just typed. So if we can do some string parsings about this, and we can even use it when we call up our calculators. So we can have our user input equals to or just input equals to our we can be like, okay, now here is something you can do. You can say number 1, and this will show you first. So whatever I write here, it'll pop up in my console here when I run the code. And I just type in a number or whatever, and I hit enter, then boom, it already grabbed my input. However, for now, my user input, they're always string. Okay, even though I typed in a number, it's going to be a string. So I have to cast this input into an integer, do something like this. I have to turn it from a string into an integer. because that's what we're going to use. Like, I'll just do number one, okay? And now if we do it again, you can see it's still 1, but your class is already, or your type has already turned from a string into an integer. And we can do the same thing here. We can go like number 2 equals to ask the user to type in number 2 here. And we can even have cal type. So we want to get the type of the calculation that we want to do. And this, we don't have to turn it into an integer anymore because it'll be a string. That's the type we want. The calculation type. And now, we can use all these 3 new user input we just taken in, and we can use them in our advanced calculator, right? Number 1, number 2, and we can have our calculation type. And we can check, okay, what's the result? Okay, we want the first number. Let's do a division again. 4 divided by 2. No, 9 divided by 2. So 9, okay, that's our first number. What's our second number? 2. What type of calculation we want to perform here? All right. Let's do a division. So divide. And here we have a user interactive calculator. And that's pretty neat. If you remember that I had a else statement that just tells the user that, sorry, your new input is invalid. And how would I do that? If I just type in some random stuff here, okay, random stuff, and my program will tell me, okay, sorry, invalid calculation type.
Maybe if you use if something.
What do you mean? You mean this if?
Like
here?
if some, like if as in code, if and then whatever you want as a error, invalid.
I'm not quite understanding your question.
If it's like if and then if it's in like whatever you want as invalid, and then after if it would be a print, sorry, and the numbers you have typed in are invalid or something.
Yes, but you never know if you're yeah, that's why I have this else here. Or you can just do something right at the top. You can go like, okay, if my type does not equal to add, and my type does not equal to minus, and my type does not equal to multiply. and my type does not equal to divide. Then I can say, okay, here I will return invalid user input. I can do it like this too. There's nothing wrong with this. So if I run the code again, I have just 2 numbers and a bunch of random things. They're invalid user input. They're the same idea, but since I'm checking if for all these calculations, then there's no need for me to check everything right off the start, which is fine. You could do this, but for me, I just choose to do it at the end. All right. So I check if it doesn't satisfy these 4 different conditions, then it's going to be the last one, right? Then it's going to be, okay, sorry, invalid calculation type. Yeah, sure. You can share your screen later. In a moment. So this is how we're going to grab our user input, right? And we can perform some actions or interactive actions. This feels more related, right? Not just the code that you're typing, but you actually get to put some user input like this. It's like a computer game or like a question, right? Any more questions or concerns? If no, I'm going to let Harper share his screen now. Okay, so no more questions. All right.
I have a question.
Okay.
When does class end?
Oh, you can leave now. It's already 9:30.
Oh, okay. So is this extension just like for Harper?
Yeah. So if you have no more questions, then feel free to leave. I'm just going to help Harper solve a little problem.
Okay, then thank you for the lesson. Bye.
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 All right. You can share your screen now.
You disabled screen sharing?
Okay. Try it again. All right. Okay. Yeah, I see why. Because you didn't turn all your input now when you take them in, they are read as a string. So number 1, number 2, they're both string now. But you want them to be numbers so you can perform some arithmetic calculations with it. In order to turn a string into an integer or a number, yes, you have to do that. Int. Yeah, if you do it like that, it should be fine. Okay, yep. Okay. So you're trying to do power here. 3 stands for power, right? Oh, I see. Yeah, multiply. Okay. Uh, how is 2 times 4 gives you 16 though?
Yeah, that's the problem.
Can you show me the code again? Okay. Oh, can you inside your cal function right up? Yeah. So can you have a new line before 20? Before line 20? Yeah. So hit enter here. Okay. Just print out your A, B, and T. Just print them out. Okay. Then since your T is 3, under L if T equals to 3, can you just print anything, even just hi? No. Under line 26. Like, yeah. No, sorry, before line 26. Okay. Huh. What? Can you run the code again? Haha.
I think like maybe it took
I your ty, you have to turn your ty into a you have to turn the type into an integer as well. Int, yeah. Because for now, without doing that, it treats it as a string. So that's why you always go into else. There you go. You got it. All right. All right. That solved your problem, I hope. So without further questions, I'm going to end this session now. And thank you, everyone. I hope you have a nice week. Bye.